Type NM cable, commonly known as Romex, is permitted for general-purpose wiring in commercial and industrial occupancies, including offices within factories, given that it adheres to Article 334 of the National Electrical Code, or NEC. However, several specific requirements govern its usage. Firstly, NM cable must be installed in a raceway or utilize another approved method for protection when exposed to potential physical damage. This stipulation aims to safeguard the cable from impacts, abrasions, or other forms of mechanical stress that could compromise its insulation and lead to electrical hazards. The raceway, typically metal or rigid non-metallic conduit, provides a robust barrier against such threats. Secondly, NM cable is prohibited from installation in wet or damp locations or where it risks exposure to corrosive fumes or vapors. This restriction is crucial because moisture and corrosive substances can degrade the cable's insulation over time, creating pathways for electrical leakage or short circuits. Environments with high humidity, standing water, or chemical processes are therefore unsuitable for NM cable unless specifically protected by methods suitable for those conditions. Thirdly, NM cable requires support via staples, straps, or other approved means at intervals not exceeding 4 feet. This requirement ensures that the cable is securely fastened along its run, preventing sagging or drooping, which could strain the conductors and potentially damage the insulation. Proper support maintains the cable's position and protects it from undue stress. Fourthly, NM cable must be terminated within an approved box or fitting. This mandate is fundamental for ensuring safe and reliable electrical connections. Approved boxes and fittings provide a secure enclosure for terminating the cable's conductors, preventing accidental contact with live parts and protecting the connections from environmental factors like dust or moisture. These enclosures are designed to meet specific safety standards and prevent electrical hazards. It is critically important to consult with a qualified electrician to guarantee that the wiring installation aligns with all pertinent codes and standards. Electrical codes, such as the NEC, are complex and multifaceted, reflecting the need for meticulous safety practices in electrical work. An electrician possesses the expertise to interpret these codes accurately, assess the specific requirements of the installation environment, and ensure that the wiring is implemented in a manner that minimizes risks and complies with the regulations. Failing to consult a qualified electrician can lead to code violations, safety hazards, and potential liability issues. Furthermore, the selection of appropriate wiring methods and materials is crucial for ensuring the long-term reliability and safety of the electrical system. Factors such as voltage drop, ampacity, and environmental conditions must be carefully considered when choosing the right type of cable and installation techniques. An electrician can assess these factors and recommend the most suitable solutions for the application. The NEC provides guidelines for calculating voltage drop, which is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can lead to dim lighting, inefficient motor operation, and other performance problems. Selecting conductors with adequate ampacity, which is the maximum current carrying capacity of a conductor, is also essential for preventing overheating and potential fire hazards. The NEC specifies ampacity ratings for various types of conductors based on their size, insulation, and installation conditions. Furthermore, environmental conditions such as temperature, humidity, and exposure to corrosive substances can significantly impact the performance and lifespan of electrical wiring. An electrician can assess these conditions and recommend appropriate wiring methods and materials that are resistant to environmental degradation. In addition to these technical considerations, it is also important to ensure that the electrical installation complies with all applicable local and state regulations. These regulations may impose additional requirements beyond those specified in the NEC, and an electrician can help navigate these complexities and ensure compliance. Proper grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. Over time, wiring and connections can degrade due to factors such as corrosion, vibration, and thermal cycling. Regular inspections can identify potential problems before they escalate into serious hazards. Maintenance activities such as tightening connections, replacing damaged wiring, and testing ground fault circuit interrupters, or GFCIs, can help prevent electrical accidents and extend the lifespan of the electrical system. GFCIs are devices that detect ground faults, which are unintended electrical currents that flow through a path other than the intended circuit. GFCIs are designed to trip quickly, interrupting the flow of electricity and preventing electrical shock hazards. The NEC requires GFCIs in various locations such as bathrooms, kitchens, and outdoor areas where there is a higher risk of electrical shock. In addition to GFCIs, arc fault circuit interrupters, or FSIs, are another important safety device. FSIs detect arc faults, which are dangerous electrical arcs that can occur in damaged or deteriorated wiring. FSIs are designed to trip quickly, interrupting the flow of electricity and preventing electrical fires. The NEC requires FSIs in various locations, such as bedrooms and living rooms, where there is a higher risk of arc faults. Surge protection is another important consideration for protecting electrical equipment from damage caused by voltage surges. Voltage surges are sudden increases in voltage that can occur due to lightning strikes, power grid switching, or other disturbances. Surge protective devices, or SPDs, are designed to divert surge currents away from sensitive electrical equipment, preventing damage. The NEC recommends SPD for various types of electrical equipment such as computers, televisions, and appliances. Proper labeling of electrical panels and circuits is essential for facilitating safe and efficient maintenance and troubleshooting. The electrical panel should be clearly labeled to indicate the purpose of each circuit breaker or fuse. Circuits should also be labeled to identify the devices or equipment they serve. Proper labeling can help prevent accidental disconnection of critical equipment and facilitate quick identification of circuit problems. Lockout/tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned back on. These procedures help ensure the safety of workers who are performing maintenance or repair on electrical equipment. In summary, the use of Type NM cable, or Romex, in commercial and industrial occupancies requires careful consideration of the NEC regulations and best practices for electrical safety. Consulting with a qualified electrician is essential for ensuring that the wiring installation complies with all applicable codes and standards and that the electrical system is safe, reliable, and efficient. Following these guidelines can help prevent electrical accidents, protect equipment from damage, and ensure the long-term performance of the electrical system. The NEC also addresses specific requirements for wiring in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC classifies hazardous locations into different classes and divisions based on the type and likelihood of the hazard. Each class and division has specific requirements for wiring methods, equipment, and installation practices. For example, in Class 1, Division 1 locations, which are areas where flammable gases or vapors are present continuously or frequently, all electrical equipment must be explosion-proof and wiring must be installed in rigid metal conduit with threaded connections. In Class 2, Division 1 locations, which are areas where combustible dusts are present continuously or frequently, all electrical equipment must be dust ignition-proof and wiring must be installed in rigid metal conduit with threaded connections. The NEC also addresses specific requirements for wiring in healthcare facilities. Healthcare facilities have unique electrical needs due to the critical nature of the equipment and the vulnerability of patients. The NEC specifies additional requirements for grounding, power reliability, and isolation of electrical systems in healthcare facilities. For example, the NEC requires that all patient care areas and healthcare facilities be equipped with isolated power systems, which are designed to prevent electrical shock hazards. Isolated power systems use a special transformer to isolate the electrical system from the building's grounding system, reducing the risk of leakage current and electrical shock. The NEC also addresses specific requirements for wiring in agricultural buildings. Agricultural buildings often have harsh environments with exposure to moisture, dust, and corrosive substances. The NEC specifies additional requirements for wiring methods, equipment, and installation practices in agricultural buildings to ensure safety and reliability. For example, the NEC requires that all wiring in agricultural buildings be protected from physical damage and corrosion. The NEC also requires that all electrical equipment in agricultural buildings be suitable for use in wet and dusty environments. The NEC also addresses specific requirements for wiring in swimming pools and spas. Swimming pools and spas have a high risk of electrical shock hazards due to the presence of water and the potential for contact with electrical equipment. The NEC specifies additional requirements for grounding, bonding, and GFCI protection in swimming pools and spas to ensure safety. For example, the NEC requires that all metal parts of swimming pools and spas be bonded together to create a common ground potential. The NEC also requires that all electrical equipment within a certain distance of a swimming pool or spa be GFCI protected. The NEC also addresses specific requirements for wiring in recreational vehicles. Recreational vehicles, or RVs, have unique electrical systems that are designed to operate on both 120 volts alternating current and 12 volts direct current. The NEC specifies additional requirements for wiring methods, equipment, and installation practices in RV to ensure safety and reliability. For example, the NEC requires that all wiring in RV be protected from physical damage and vibration. The NEC also requires that all electrical equipment in RV be suitable for use in a mobile environment. The NEC also addresses specific requirements for wiring in marinas and boatyards. Marinas and boatyards have a high risk of electrical shock hazards due to the presence of water and the potential for contact with electrical equipment. The NEC specifies additional requirements for grounding, bonding, and GFCI protection in marinas and boatyards to ensure safety. For example, the NEC requires that all metal parts of docks and boats be bonded together to create a common ground potential. The NEC also requires that all electrical equipment within a certain distance of the water be GFCI protected. The NEC also addresses specific requirements for wiring in temporary installations. Temporary installations are electrical systems that are used for a limited period of time, such as during construction or events. The NEC specifies additional requirements for wiring methods, equipment, and installation practices in temporary installations to ensure safety. For example, the NEC requires that all wiring in temporary installations be protected from physical damage and weather. The NEC also requires that all electrical equipment in temporary installations be GFCI protected. The NEC is a comprehensive set of standards that covers all aspects of electrical wiring and installation. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements to ensure the safety of electrical systems. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest edition of the NEC to ensure compliance with current regulations. In addition to the NEC, there are also various other standards and regulations that may apply to electrical installations. These standards and regulations may be issued by federal, state, or local authorities. It is important to be aware of all applicable standards and regulations and to follow them to ensure the safety of electrical systems. The NEC provides guidance on how to select the appropriate size of conductors for electrical circuits. The size of conductors is determined by the ampacity, which is the maximum current carrying capacity of the conductor. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation, and installation conditions. It is important to select conductors that have sufficient ampacity to carry the expected load of the circuit. If the conductors are too small, they may overheat and cause a fire. The NEC also provides guidance on how to calculate the voltage drop in electrical circuits. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can lead to dim lighting, inefficient motor operation, and other performance problems. The NEC provides formulas for calculating voltage drop based on the length of the circuit, the size of the conductors, and the current flowing through the circuit. It is important to select conductors that are large enough to minimize voltage drop. The NEC also provides guidance on how to protect electrical circuits from overcurrent. Overcurrent is a condition in which the current flowing through a circuit exceeds the rated ampacity of the conductors. Overcurrent can be caused by short circuits, ground faults, or overloads. The NEC requires that all electrical circuits be protected from overcurrent by circuit breakers or fuses. Circuit breakers and fuses are designed to trip or blow when the current exceeds a certain level, interrupting the flow of electricity and preventing damage to the conductors. The NEC also provides guidance on how to ground electrical systems. Grounding is the process of connecting the electrical system to the earth. Grounding provides a low impedance path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures. The NEC also provides guidance on how to bond metal enclosures. Bonding is the process of connecting metal enclosures together to create a common ground potential. Bonding helps to prevent electrical shock hazards by ensuring that all metal enclosures are at the same voltage. The NEC specifies detailed requirements for bonding metal enclosures, including the size and type of bonding conductors and the methods for connecting the bonding conductors to the enclosures. The NEC also provides guidance on how to install electrical boxes and fittings. Electrical boxes and fittings are used to enclose and protect electrical connections. The NEC specifies requirements for the type and size of electrical boxes and fittings that must be used in various locations. The NEC also specifies requirements for how to install electrical boxes and fittings to ensure that they are securely mounted and properly grounded. The NEC also provides guidance on how to install electrical wiring in various types of buildings. The NEC specifies different requirements for wiring in residential, commercial, and industrial buildings. The NEC also specifies different requirements for wiring in hazardous locations, healthcare facilities, agricultural buildings, swimming pools and spas, recreational vehicles, marinas and boatyards, and temporary installations. The NEC is a complex and comprehensive set of standards that covers all aspects of electrical wiring and installation. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements to ensure the safety of electrical systems.